Okay, in this video lecture we want to talk about timers, and in particular how to use a timer to create a non-blocking delay. We've already talked a little about timers, but in here we're going to go into a lot more depth about using them and the various uses you could do. We have 5 16-bit timer modules called timer 1 through timer 5. But you can combine timer 2 and 3 to create a 32-bit timer called timer 23 or timer 2-3. And you can combine timer 4 and 5 to make a 32-bit timer called timer 4-5. The 32-bit timers let you measure much longer amounts of times. Okay, so what does a timer do? As we've already seen, what a timer is, it's really a counter. And what it counts is the rising edge of the peripheral clock. Okay? Or if you change the prescalers, it can measure multiples of the clock edges. But we'll usually just talk about measuring every edge right now. Right? Now, it's going to measure these edges up to a number called period. And the next time it counts an edge, that edge is now 0. So the counter has rolled back or rolled over to 0. That means, in fact, that the period is actually period plus 1. And with this period, right, this counter, you can always check the value or read the value of the counter. And you can always check whether or not the flag has been set. Right? Okay. And anytime you want, you can clear or zero the counter and clear the flag as well. Here's the code, right, for doing that. Right? Open timer X, X is 1 through 5. Config, we'll talk about in a second. Period is the number between 0 and 65535 in 16-bit mode. And in 32-bit mode, it's between 0 and 4 point something billion, right? So you can read the time using this function, read timer X, right? And you can get the status of the flag by MT2, say, get int flag. Okay? You can start the timer at 0 or restart it at any time you want to 0, and you can always clear the flag. Now, this is how you set up configuration. You turn your timer on, you say that you want to use the peripheral bus clock, so T1 through 5 source internal. This only needs to be worried about if you're using timer 1. And then the multiples of edges are given by these guys, 1, 2, 4, 8, 16, 32, 64. I'm pretty sure 128 isn't one of them. 256. Okay. I don't know why I have 128. I'm sure it's not one of the choices. As well, there's something you note that timer 1 is slightly different. It doesn't have 2, 4, 16, or 32. So it's got a more limited number of prescale values. When you want to use the timer in 32-bit mode, you just say this. Remember, this only works if you're using timer 2 or timer 4. Then it slaves or chains timer 3 and timer 5 to these timers. And here's the value of period, 1 through 2 to the 16 minus 1, and 1 to 2 to the 32 minus 1. Okay, here's the formula that you need to know. The period, the amount of time that you want to measure, is given by the period, the setting in the function, right? So that's period right here, and minus the value you set in the timer. Okay, so let me get that function again, right here. Usually we set it to 0. There are reasons why you could set it at a bigger number, but I'll show you that a little later. Okay? Times whatever the prescale is, and then you multiply by 1 over 8 million, what we've been typically doing, the instruction cycle time. Okay, now typically the question is that you need to have a particular amount of time. So say you're running at 8 megahertz, and we're going to start the timer at 0. What period setting and prescale setting do we need if the period is to be 2 seconds? Remember, if I use a 16-bit timer, period can only go up to 65536. Okay? The prescalers are like this, right? If we're using a timer 2, 3, 4, or 5. Well, you had to take this equation. We're going to start with 0, so we can ignore that, and invert it. So 8 million megahertz times time is 2, and we've got to get a number that's less than 65536. So that tells you which n to set, and when you set that in, that tells you what period to pick. Okay? Okay. Now that is actually probably period plus 1, so you might need to subtract 1 if you're really fussy about how close you get to that time. So why would we use timers, right? If we want a 2-second delay, why don't we just use the delay milliseconds function that I've given you with 20,000 in it? That'll give me a 2,000. That'll give me a 2-second delay. Well, the reason for that is that when you use that function, delay millisec, you can't do other things. It's called a blocking delay. And with timers, you can actually set them up so instead of just killing time in a function, you can do other things. Let's look at the code. Okay, here's the code. It's very simple, right? You configure your timer for the correct amount of time. So this will configure it for 2 seconds. You clear the flag, and you set the timer to 0. Now in the background, the counter is counting the time. And the way you know when to get out of whatever you're doing, you wait for the flag to pop, right, to be set, right? So while nothing's going on, you can do other stuff. I'm going to give you an example of a piece of code which does that. Okay, this is called unresponsive function. So I'm going to use a button for an LED, and it's initially off, and another pin for a button and a pin for an LED. And here's our usual button code for checking or polling the status of whether or not a button is pressed. Right? And so this line is for the button being pressed. Okay? So what I have in here is a little delay, a very small delay. And the reason for that is called a debouncing delay. Sometimes on your buttons, particularly if they're a little older, when you press the button, you might make contact a couple of times. So having a little delay sort of prevents you from having it look like you press the button 3 or 4 times. And we've got this blink rate. And what this blink rate is supposed to do, we want to have several different blink rates for the LED. The first case is off. The next one is a fairly fast blink. The next one is a very slow blink, 2 seconds on, 2 seconds off, and then full on. So I have that code on my pick right now, but I've also added a bit of code that prints out what the blink rate is, right? So this is the blink rate each time we get called. So I'm going to look at that code, and as I press a button, the first button, it says, oh, blink rate is 1, good. Press again, blink rate is 2, perfect. But now I start pressing and I don't get any response. And the reason for that is the delays for 2 seconds. We're not checking the code. Come on. Ah, look, I got it. Right? That was almost accidentally. Press 0, that responds quickly, 1 responds quickly, 2 responds quickly, but then when I'm waiting to get 3, it's only almost by luck that I ever get it to turn. So that's an example of an unresponsive button because my delays are too big. If I had short delays, no problem, we could live with it. But these long delays, really horrible. So what are we going to do? So here's my fixed version of the unresponsive button. Still the timer is set up for a 2-second delay, right? And I've made a couple of changes, okay? One is a couple of lines of code have been put into a separate function, right? All it does is it checks the port to see if the button has been pressed, right? All that same code we had before, right? So it's just been put in a separate function to make this code a little more readable. But where I had the really long delays, now I've got this blink rate control. So for the 2 seconds that we're waiting, right, we can do other things. That is, check to see whether or not a button has been pressed. And that's what this is doing here. And same for the off. I've done the same thing with the 25 milliseconds just to be consistent, that I have the same sort of code. But what I've done is I've started write timer 2 much later, not at 0. And if I do the calculation, I can see that's about 25 milliseconds. So I'm going to compile that and load that in, and I'll pause while I do that. Okay, I'm back. I've loaded this program onto the PIC, and now let's look at the PuTTY terminal screen, right? So I press a button, 1 works, 2 works. Oh, look, it's responding really nicely every time. That's because I've actually given it code, right? This code in here, right? This code in here is while we're waiting for the 2 seconds to be up, or the 25 milliseconds, I want to be here, right? All the time we're in this while loop waiting for the flag tells me 2 seconds are up. I'm doing the button check, polling the button, okay? Nice, simple code. That's the basic way we're going to use the timer. It's not the only way. There's some other ones that we're going to use as well. That's all for now. Thank you.